Right, for the number 1 through 4, the directions say evaluate the integrals using algebraic substitution, completing the square, separating fractions, long division, or trigonometric identities. It also should include multiplying by the conjugate. So basically, if you're stuck at all, try to look up at the list and see if there's one that you can choose. All right, on this first one, it says to find the integral from 0 to 1/2 e to the 4x minus 2 over e to the 4x. I am going to choose to separate the numerator on this one. So I'm going to make this e to the 4x over e to the 4x minus the integral of 2 over e to the 4x. This first one will simplify into the integral of 1, and then minus the second one will simplify into 2e to the negative 4x. All right, and then if you choose to do a use substitution on this one, or just know that what the integral of e to the negative 4x is, we'll see. The integral of 1 is x, and then this one will bring down the 2, and then the integral of e to the negative 4x is negative 1/4 e to the negative 4x. Remember, this is just the reciprocal of when you take the derivative of an e to the u. So from here I'm going to have x minus, actually that will turn into plus 1/2 e to the negative 4x, and then instead of putting plus c, we will evaluate it at 1/2 and at 0. So if I plug in 1/2, I'm going to get 1/2 plus 1/2 times, if I plug 1/2 in there, I will get negative 4 times 1/2, which is e to the negative 2, and then minus, if I plug 0 in, I'll get 0 plus 1/2, and I'll get e to the 0, and e to the 0 is just 1, so that's what I'll get. So now I have 1/2 plus 1/2 e to the negative 2 minus 1/2, so my 1/2s cancel, so I'm just left with 1/2 e to the negative 2, and then so I don't have a negative power, I can bring that down and make it 1 over 2e squared for that answer. All right, problem 2, the integral of x cubed minus 8x squared plus 3x plus 16 all over x squared minus 2. I do notice that the degree of the numerator is greater than the degree of the denominator, so I am going to use long division on this one. So x squared minus 2 into x cubed minus 8x squared plus 3x plus 16. Okay, when I do long division, x squared times x would give me x cubed, and now I'm going to divide or multiply. X times x squared is going to be x cubed. X times negative 2 is going to be negative 2x. Please notice that I put it over with the x term. So now I'm going to subtract. And so these will cancel out. I'll be left with negative x squared. And then if I bring this down, that will end up being plus 5x, and then bring down your 16. All right, so now x squared times what would give me negative 8x squared? That would be minus 8. And then we would go ahead and distribute again. Negative 8 times x squared is negative 8x squared, and negative 8 times negative 2 is is a positive 16. So then I will subtract. This will cancel out, bring down my 5x, and these also cancel out and give me 0. So my remainder is 5x. So the x squared minus 2 went in there x minus 8 times, and then I have a remainder of 5x over x squared minus 2. So now I have 3 parts I'm going to take the integral of. The first one would just be 1/2 x squared, and then minus the integral of 8 would be 8x. And then on this third one, I'm going to do a u substitution. I'm going to let u equal x squared minus 2. So du will equal 2x. So I need a 2 here, so I'm going to actually multiply by 2/5. So on the outside, I'm going to multiply by 5/2. So on this part, I will now have plus 5/2 the integral of du over u, and that's an ln, so I'm going to have 1/2 x squared minus 8x plus 5/2 natural log of u, which would be natural log of x squared minus 2 plus c. Problem 3, the integral of dx over 2x squared minus 4x plus 14. I will be on this one because this will not factor, I don't believe. We're going to do completing the square. Before I do that, though, I'm actually going to factor out a 2 from everything. So this will be 2x squared minus 2x plus 7. And then I'm going to bump this 2 out front, so this will actually now be 1/2 dx over x squared minus 2x plus 7. If you didn't do that, you can still get an answer. It's just a little bit more difficult. All right, I'm going to complete the square at this point in time. So I'm going to put x squared minus 2x, leave myself a blank, and put plus 7. When I complete the square, negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. And then on the outside, I'm going to put on minus 1. So this now gives me 1/2 the integral of dx over x squared minus 2x plus 1 would be x minus 1 squared plus 6. And because it is set up like an a squared plus u squared plus a squared, it is going to be arctan. My u is going to be x minus 1, so my du will be 1, which is fine. And then my a will be the square root of x. So when I do this problem, I have a 1/2. And then with arctan, it's going to be 1 over a, so 1 over the square root of 6. Arctan u over a. And then I'm just going to simplify this a little bit, so I'll have 1 over 2 square root of 6. Arctan x minus 1 over the square root of 6 plus c. All right, problem 4, we have 8 tangent x over the secant x minus 1. On this one, really none of those other tricks are going to work nicely, so we're going to multiply by the conjugate. So we're going to multiply by secant x plus 1 over secant x plus 1. And then I'm going to go ahead and multiply. I'm going to get 8 tangent x secant x plus 8 tangent x. And this will be over, if I multiply that out, I'll get secant squared x minus 1. And then from here, we do have an identity that says 1 plus tangent squared x is equal to secant squared x, which means that secant squared x minus 1 is going to equal tangent squared. So I'm now going to make this 8 tangent x secant x plus 8 tangent x over tangent squared x. And now, since I have a plus sign in the numerator, I'm going to separate the numerators. So I'm going to get 8 tangent x secant x over tangent squared x, and then plus the integral of 8 tangent x over tangent squared x. And now I can cancel out one of the tangents. So on this one, I'm going to be left with 8 secant x over tangent x. And then in this one, I'm going to be left with 8 over tangent x. All right, I'm going to strictly stick with the left side until I'm done with that. Doesn't look like there's really anything I can do with that one, so I usually like to turn things back in terms of sine and cosine, and I'm actually going to bump the 8 out front as well. So this will be 1 over cosine x divided by tangent is sine over the cosine x. So if I multiply by the reciprocal, I'm going to have 1 over cosine x times cosine x over sine x. So the cosines cancel, so I'm now left with 8 times 1 over the integral of 1 over sine x, and 1 over sine is equal to cosecant. And then we do have an integral for cosecant. It is negative natural log cosecant x plus cotangent x. So that one is done. And then this one, the second part, if I bring the tangent up top, this would be 8 cotangent x, and the derivative, the integral of cotangent is natural log of sine. So this will be plus 8 natural log of sine of x. And then I do believe I'm done, except for the plus c.